Start, sir.
Thank you, sir. Again, welcome back, dear student, to the online webinar classes for intermediate students, which is conducted by Tri Society, Hyderabad. This is again Mahipal Reddy, PGT Maths, Peddapur Camp, Jagitchal District. So, MATHS-2B, continuous topic, yesterday continuous topic, the chapter 7, definite integration. So, today is the day 6. Before start the day 6 class, so recapitulation what we learned yesterday. Yesterday we learned some examples related on the integration by parts method and integration of the form 1 by a sin x plus b cos x plus c with respect to the x variable, and some examples we solved yesterday, as well as one problem we completed yesterday, exercise 7b third bit. Already first bit, second bit are completed day before yesterday, and yesterday we completed one problem from the exercise 7b third bit. So this is also related to the integration by parts method. That means integration u into v method. Integration u into v equals to u into integration of v minus integration u dash into integration v. That is a formula to find the by parts method. And again, another one is integration of 1 by a sin x plus b cos x plus c. So when it is given in this form, we substituted sin x equals to 2t by 1 minus 1 plus t square, and cos x equals to 1 minus t square by 1 plus t square, and another one is dx equals to 2 dt by 1 plus t square. So continuous topic of the yesterday. Today day 6. What we have to learn today? Day 6. The remaining problems of the exercise 7b third bit. So remaining problems of the exercise 7b third bit. From this bit, there is a 7-mark question will be covered in the IPE examination. Important bit, 7-mark question will be covered from this exercise only. That is also especially from the third bit. So yesterday we solved one problem from the third bit. What is the third bit actually is here? Evaluate the following integrals. So in that fifth question, integration 0 to pi by 2, definite integration, lower limit is 0, upper limit is pi by 2, a sin x plus b cos x by sin x plus cos x with respect to the x variable. We have to find the value of this. Integration 0 to pi by 2, a sin x plus b cos x sin x plus by sin x plus cos x dx. So solution, let what I am taking is here, what is the given question? That is I am taking is here a equals to 0 to pi by 2, integration 0 to pi by 2, a sin x plus b cos x by sin x plus cos x dx. That is equation number 1. So what is the given in the question? That is I am taking is here equation 1, as well as I am taking this is the a, capital A, otherwise we can choose the capital I also. A equals to integration 0 to pi by 2, a sin x plus b cos x by sin x plus cos x dx. It is equation number 1. And we know that the property, this is already important property. Integration 0 to a f of x dx. F of x dx equals to integration 0 to a f of a minus x. Just the x variable is replaced as a minus x. So here x can be written as pi minus x. And here also the x, another x variable in the cos x, we can replace as a pi minus x. And here also we can write the pi minus 6, and here also pi minus 6, because we know that the one property, integration 0 to a f of x dx equals to integration 0 to a f of a minus 6. So what is next step? When it is substituted, it become now a equals to integration 0 to pi by 2, the coefficient a same as t is sin x become now here sin x replaced as upper limit minus x variable. pi by 2 minus 6. And here also the another x cos x also replaced as pi by 2 minus 6. By the denominator sin x, it is now pi by 2 minus 6. And here also one more plus cos x is there. The x is replaced as pi by 2 minus 6. So this is a property we know that f of a minus 6. So what is happen now is here? Sine pi by 2 minus 6. Sine 90 degrees. Sine 90 minus theta. This is become now simply cos x. And this is now cos pi by 2 minus 6 is sin x. And here also sin pi by 2 minus 6 is a cos x, and cos pi by 2 minus 6 is sin x. So this is one of the complementary angles. So therefore, what is the next one? A equals to, left side a equals to integration 0 to pi by 2 a cos x plus b sin x by cos x plus sin x, because here sin 90 minus x is cos x, cos 90 minus x is sin x, and here also sin 90 minus x is cos x, and cos 90 minus x is sin x dx. This is the equation number 2. I am taking this equation number 2. So what we have to do is here add equation 1 and 2. What is the equation 1 and 2? Left side values are both are a and a. Therefore, a plus a. And right side values equals to integration 0 to pi by 2. What is the equation number 1 is here? Equation 1 is a sin x plus b cos x by sin x plus cos x with respect to the x variable. And what is the equation 2 is here? Integration 0 to pi by 2 a cos x plus b sin x by cos x plus sin x. Dear student, observe the denominator in the both the values sin x plus cos x. Denominator of the first one is the sin x plus cos x, and the second one is also cos x plus sin x. That nothing but sin x plus cos x only. So both are like fractions. So the right side value, left side value is a plus a is 2a, and it is a common integration. Different integration is same 0 to pi by 2. Here also 0 to pi by 2. I am writing the 0 to pi by 2 as a single. And both are the like fractions. Therefore, the LCM is sin x plus cos x. LCM is sin x plus cos x. And what is there is here a sin x plus b cos x. I am writing this a sin x plus b cos x plus a cos x plus b sin x. And now a terms a sin x, a cos x. In that a common, and these two remaining b cos x, b sin x. I will take the b is the common. Okay. So what is the next one? So left side 2a equals to integration 0 to pi by 2. When the a terms, there are two a terms are there, a common sin x plus cos x, plus b is also common cos x plus sin x. So here also from these two terms, this is sin x plus cos x, and it is also sin x plus cos x. Again, these two terms are common. What is the next one? 2a equals to a plus b into sin x plus cos x. A plus b into sin x plus cos x by sin x plus cos x. So sin x plus cos x, numerator and denominator get cancelled. And I will write the a plus b outside because it is a one value, numerical value. So what is the now? As well as send this 2 also. Left side 2, multiplication 2, send to other side. It become now a plus b by 2. Integration 0 to pi by 2. These are sin x plus cos x. Both are get cancelled, numerator, denominator. The remaining is 1 only, 1 dx. So a equals to a plus b by 2. Integration of 1 with respect to the x variable is x. So integration of 1 with respect to the x variable is x. Lower limit is 0. Upper limit is pi by 2. Now substitute the upper limit minus lower limit. Okay. I'm going to substitute the upper limit as well as the lower limit. What is the next step is here? So a equals to a plus b by 2 into upper limit is pi by 2 minus lower limit is 0. Pi by 2 minus 0. Pi by 2 minus 0 is pi by 2. Pi by 2. So a plus b into pi, 2 by 2 into 2. 2 into 2 is 4. This is the definite integration of what is the given question here. The given question. Therefore, integration 0 to pi by 2 a sin x plus b cos x by sin x plus cos x dx equals to a plus b into pi by 4. This is the value of the given question, definite integration. Next, go to the another problem. Third bit, sixth problem. Integration 0 to a x into a minus x whole power n. A minus x whole power n dx. Integration 0 to a x into a minus x whole power n dx. Solution. This is already we know that properties. Integration 0 to a f of x dx equals to integration 0 to a f of a minus x. So therefore, what is the given question here? Integration 0 to a x into a minus x whole power n. I am writing as it is. Here the x is replaced as upper limit minus x variable. So this is the x become now a minus x according to this formula, this property. X replaced as a minus x. And here also the one more x I have to replace is here. A minus x. So it become now integration 0 to a minus x into a minus of a minus x all power n as it is, all power n as it is into dx variable. Dear student, don't confuse here. Just I am I'm using this property integration 0 to a f of x dx. It is equals to integration 0 to a f of a minus x dx. So it is equals to integration 0 to a. This x is replaced as a minus x into a minus of x. X nothing but again a minus x all power n dx. So now integration 0 to a. This is a minus x as it is. When you open the bracket, this has become now a as it is minus a. This is minus into minus is the x become the plus x is here. X become the minus x become the plus x because minus of minus x is the plus x. So here plus a minus a get cancelled. These two a and a plus a minus a get cancelled. Only the remaining is x only. Now next step. What is the next step is here? Integration 0 to a minus x. Here the remaining is x only, x power n dx. Now this x power n multiply with a. What is become now? A into x power n. And this x power n multiplied with x power n is multiplied with x. It become now x power n plus 1. X power n plus 1. So what is the next step here? Multiply the x power n within the bracket 2 terms. So it is integration 0 to a into x power n because a multiplied with x power n. It become now a into x power n minus x into x power n. X into x power n is x power n plus 1 dx. It become now we have to do the integration. This is a outside I am written as it is. X power n integration we know that x power n plus 1 by n plus 1. X power n integration, this is the first formula we learned in the 6th chapter. And lower limit is 0, upper limit is a. X power n integration is x power n plus 1 by n plus 1. And integration of x power n plus 1. Integration of x power n plus 1, nothing but x power n plus 1 plus 1 by n plus 1 by plus 1. N plus 1 become nothing but n plus 2. So integration of x power n plus 1 is x power n plus 2 by n plus 2. Lower limit is 0, upper limit is a. Okay. So what is the next step is here? Apply the upper limit as well as the lower limit. Upper limit, what is upper limit? The first one is substitute the a. This become now a by first outside a into a power n plus 1 by n plus 1. When you substitute the 0, lower limit is 0, this total is 0. And again the upper limit in the second one is, upper limit is a. So it become now a power n plus 2 by n plus 2. And substitute the lower limit is also. So when you substitute the lower limit, it becomes 0. Lower limit is 0 because therefore the value is also 0. Okay. So this is multiply a also now within the bracket term, a into a power n plus 1. A into a power n plus 1. It become now a power n plus 2, because a into a power n plus 1 is a power n plus 2 by n plus 1 minus a power n plus 2 by n plus 2. So both are both are now, what is the common is here? N plus 2 common. N plus 2 common. And here the denominator is n plus 1. Here the denominator is n plus 2. So both a power n plus 2 common in the both the terms. And denominator of the first term is n plus 1 and second term is n plus 2. So these are unlike fractions. Find the LCM. What is now? Actually, I'm taking the a power n plus 2 is common. LCM is n plus 1 into n plus 2. When it is LCM now, 1 into n plus 2 minus 1 into n plus 1. Minus 1 into n plus 1, nothing but minus 1 minus n minus 1. So plus n minus n get cancel. Plus n minus n get cancel. And remaining is 2 minus 1. 2 minus 1, nothing but 1 only. So 1 is no need to write here. Therefore, it is equals to a power n plus 2 by n plus 1 into n plus 2. Therefore, integration 0 to a x into a power n, a power x all power n dx equals to a power n plus 2 by n plus 1 into n plus 2. Next, another problem, exercise 7b. Third bit, 11th question. This is very, very important. So many times, number of times it is repeated, the 7-mark question. Very important problem in the IP examination, 7-mark question. Integration 0 to 1. Integration 0 to 1 log of 1 plus x by 1 plus x square dx. Integration 0 to 1 log of 1 plus x by 1 plus x square dx. Dear student, very important problem in the IP examination. So many times, number of times it is repeated in the IP examination as the 7-mark question. So children, listen carefully. Solution. So this problem I will solve by the substitution method. Substitution method. So what I am taking is here x equals to I'm taking is here tan theta. X equals to tan theta. I'm going to solve by substitution method. I'm taking the x equals to tan theta. Derivative with respect to x on both sides. Derivative with respect to x on both sides. So x x derivative is dx. It is equals to tan derivative. Tan derivative is sec square. Tan derivative is sec square. Tan theta derivative is sec square theta. And with variable x variable, therefore into d theta. Actually, x derivative is 1. It is equals to tan theta derivative with respect to x variable is sec square theta into d theta by dx. Carry the dx to the left side. Therefore, dx equals to sec square theta into d theta. Now, this is a different integration. So we have to change the limits also, because when you follow the substitution method, that means one variable is transforming into another variable. Therefore, the limits will be also, we have to transform. So first lower limit is, what is the lower limit is here? Lower limit is 0. That means x equals to 0. From here, what is the theta value? Because x equals to tan theta. X equals to tan theta. Therefore, theta equals to tan inverse of x. Tan inverse of inverse trigonometry. X equals to tan theta. Theta equals to tan inverse of x. It is equals to tan inverse of x. X value, first lower limit. What is the lower limit is here? 0. Tan inverse of 0. So tan inverse of 0 is 0, because tan 0 degree value is 0. And what is the upper limit is here? Upper limit is 1. So take the upper limit is 1. So x equals to 1. Upper limit. Same, theta equals to tan inverse of x. Theta equals to tan inverse of, because x equals to tan theta. So theta equals to tan inverse of x. That means, so tan inverse of 1. Tan inverse of 1. Tan inverse of 1 is equals to pi by 4, because tan pi by 4 value is 1. Tan 45 degrees value is 1. So dear student, listen carefully. Again, I have one more. What I am choosing here, x equals to tan theta. I am taking this. Derivative with respect to x on both sides. Derivative with respect to x on both sides. Then when it is derivative on the both side, it become dx equals to sec square theta into d theta. So limits also we have to change. Lower limit is 1. So x value, lower limit is 0. X equals to 0. That implies theta equals to tan inverse of x. Tan inverse of x, x value 0. Tan inverse of 0 equals to 0. And x equals, upper limit is 1. So theta equals to tan inverse of x, nothing but tan inverse of 1 is nothing but pi by 4, because tan 45 degrees value is 1. So now we have to substitute the x value in the given question, and we have to substitute the dx value also in the given question, and we have to substitute the changing the lower limit and upper limit is also in the given question. Okay, so what is the now? What is become this? Therefore, integration, actually the given question is integration 0 to 1 log of 1 plus x by 1 plus x square dx. The given question is integration 0 to 1 log of 1 plus x by 1 plus x square dx. It is equals to here integration 0, lower limit is same, but upper limit, when upper limit is 1 with respect to the x variable, then upper limit is pi by 4 with respect to the t variable, and into log x, log 1 plus x. What we choose here, x value is tan theta. So log of 1 plus tan theta by 1 plus x square is nothing but again 1 plus tan square theta, because x value we choose here tan square theta. And when you derivative on both sides, we got dx equals to sec square theta into d theta. Sec square theta into d theta. That means now it is transformed into integration 0 to pi by 4 log of 1 plus tan theta by 1 plus tan square theta into sec square theta plus d theta. Dear student, what is the value of the denominator? 1 plus tan square theta. 1 plus tan square theta value is sec square theta, because from the trigonometry identities, second identity. So it is now integration 0 to pi by 4 log of 1 plus tan theta by 1 plus tan square theta value is sec square theta. 1 plus tan square theta value is sec square theta into sec square theta d theta into sec square theta d theta. Now sec square theta get cancelled. Sec square theta get cancelled. So what is the remaining now here? A equals to, actually we are taking is that A equals to integration 0 to pi by 4 only the log of 1 plus tan theta, 1 plus tan theta d theta. Let this equation number 1. Let this equation number 1. Dear student, actually this is the, from here in the exercise there is one more question is also there. This is one more question is also there. When the question is given in this form, this is a 4 marks question will be covered in the examination. That means evaluate integration 0 to pi by 4 log of 1 plus tan theta d theta. This is actually one more question is there in the exercise. That question is the 4 marks question. And actually the 11th problem, integration 0 to 1 log of 1 plus x by 1 plus x square dx. It is a 7-mark question. What is become now? We know the property again. Integration 0 to a f of x dx equals to integration 0 to a f of a minus x dx. This is the property, we know that. That means the theta variable is here replaced as pi by 4 minus theta. Here the variable is theta and upper limit is pi by 4. So replace the theta is pi by 4 minus theta. So it is now just I'm replacing the theta value only as pi by 4 minus theta. Therefore, A equals to integration 0 to pi by 4 log of 1 plus tan pi by 4 minus theta d theta. Dear student, this is the form of the, now look at this, tan A minus B formula. Tan A minus B formula is tan A minus tan B by 1 plus tan A into tan B. As well as we have the one more formula is also there, tan pi by 4 minus theta. This is a problem actually in the first year 1A trigonometric ratios up to transformation. So tan pi by 4 minus theta value is 1 minus theta by 1 plus theta. 1 minus theta by 1 plus theta. That is a problem we solved in the previous year, previous class. That means tan pi by 4 minus theta equals to 1 minus tan theta by 1 plus tan theta. Therefore, it is equals to A equals to integration 0 to pi by 4, 0 to pi by 4 log of 1 plus, so tan pi by 4 minus theta value. Tan pi by 4 minus theta value. Tan pi by 4 minus theta value is 1 minus tan theta by 1 plus tan theta. 1 minus tan theta by 1 plus tan theta. Therefore, A equals to integration 0 to pi by 4 log of, here the denominator is 1. So now 1 and one more denominator is 1 plus tan theta. So LCM of these two is 1 plus tan theta. I'm writing the 1 plus tan theta. Then when they take the LCM, this is 1 into tan theta, 1 into 1 plus tan theta, and another numerator is 1 minus tan theta. 1 minus tan theta. So what is happened now? plus tan theta minus tan theta get cancelled. Plus tan theta minus tan theta get cancelled. So remaining is only the 1 plus 1. 1 plus 1 is 2 by 1 plus tan theta. That means A equals to integration 0 to pi by 4 log of 2 by 1 plus tan theta d theta. Student, we know that this is a log A by B. Second law of logarithm. Log A by B is nothing but log A minus log B. So it is now log 2, numerator log 2 minus log 1 plus tan theta. Log 2 minus log of 1 plus tan theta. Therefore, A equals to integration 0 to pi by 4 log 2 minus log of 1 plus tan theta d theta. So next step, what I'm writing the definite integration individual f of f minus g formula, integration f minus integration g. So A equals to integration 0 to pi by 4 log 2 d theta minus integration 0 to pi by 4 log of 1 plus tan theta d theta. Dear student, this is actually equation 1. This is the equation 1. Equation 1, what is equation 1? A equals to integration 0 to pi by 4 log of 1 plus tan theta d theta. Therefore, it is replaced as now. This is the value of the A only. This is the value of the A. And log 2 is a numerical value. I'm writing the outside log 2. Log 2 into integration 0 to pi by 4. Only the remaining is 1 into theta variable d theta. And this is actually the A. Okay, from the equation 1, this is we are chosen as the equation 1A. So bring this A minus A to the right side, left side. It become now A plus A, nothing but 2A into log 2 into integration 0 to pi by 4, 1 d theta. So A plus A is the 2 theta equals to log 2 integration of 1 with respect to theta variable. So with respect to theta variable, integration of 1 is theta. Lower limit is 0, upper limit is pi by 4. So 2a equals to log 2 into theta, lower limit is 0, upper limit is pi by 4. Substitute the upper limit and lower limit and send this left side 2 also. 2a is there left side. Send this 2 to the other side. A equals to 1 by 2 into log 2. Upper limit is pi by 4 minus lower limit is 0. Pi by 4 minus 0. So what is become now? A equals to, this is pi by 4 minus 0 is nothing but pi by 4. So pi by 4, denominator 2 into 4 is 8 into pi into log 2. So A equals to pi by 8 log 2 value. Therefore, integration 0 to 1 log of 1 plus x by 1 plus x square dx equals to pi by 8 log 2. Pi by 8 log 2. This is an important problem. So many times repeated in the 7-mark question. I will explain one more time. Listen carefully, dear student. So the given question is integration 0 to 1 log of 1 plus x by 1 plus x square dx. So x equals to what you are taking is here x equals to tan theta. Derivative with respect to x on both sides. Dx equals to sec square theta d theta. This is a definite integration. Therefore, we have to change the limits also. Lower limit is 0 with respect to the x variable as well as the lower limit is also 0 with respect to the theta variable. And upper limit is 1 with respect to x variable, then the upper limit is pi by 4 with respect to theta variable. All the values we have to substitute here. So when you substitute is here, it become now integration 0 to pi by 4 log of 1 plus tan theta by 1 plus tan square theta into sec square theta into d theta. So 1 is sec square get cancelled. And I am taking this is equation 1 as well as the A also. Because we will use this value, A value later in the problem. So A equals to integration 0 to pi by 4 log of 1 plus tan theta into d theta, equation number 1. And we know that the form property integration 0 to a f of x dx equals to integration 0 to a f of a minus x. It become now integration 0 to pi by 4 log of 1 plus theta is replaced as pi by 4 minus theta because upper limit is pi by 4. So again we know the formula tan pi by 4 minus theta. Tan pi by 4 minus theta value is 1 minus tan theta by 1 plus tan theta. And find the LCM also. LCM. Yeah, here the LCM we have to find. One LCM is 1 plus tan theta. So numerator become now 1 plus tan theta plus 1 minus tan theta. Plus tan theta minus tan theta get cancelled. The remaining is numerator is 2 only. 2 by 1 plus tan theta. Again, this is a form of the log A by B. Log A minus log B. Log 2 minus log 1 plus tan theta. So writing the integration individually. A equals to integration 0 to pi by 4 log 2 d theta equals minus integration 0 to pi by 4 log A tan theta d theta. From equation 1, this total value is capital A only. This is the value of the A only. So I have to replace that value is the A. So A equals to log 2 integration 0 to pi by 4 1 d theta, and this total value is A. So we carry the minus A to the left side, become the plus A plus A, and right side same as it is. A plus A equals to 2A log 2 and integration of 1 with respect to theta variable is theta. Lower limit is 0 and upper limit is pi by 4. Substitute the upper limit minus lower limit, pi by 4 minus 0. It is the pi by 4 only. Pi by 4 into 1 by 2 is pi by 8 into log 2. This is a solution of the given question. Important problem this is. Another problem. Third bit 17th question. Integration 0 to 1 sine inverse of 2x by 1 plus x square dx. Integration 0 to 1 sine inverse of 2x by 1 plus x square dx. Here also I am taking the x equals to tan theta. X equals to tan theta derivative with respect to x variable. Dx equals to sec square theta d theta as it is. That's the previous problem. And the limits also same. Lower limit is 0. Then lower limit will be changed to the 0 also. Same. X equals to 0. Lower limit is 0 with respect to x variable. Tan inverse of x, nothing but tan inverse of 0 is nothing but 0 only. And x equals to 1, upper limit is 1. This implies theta equals to tan inverse of x, nothing but tan inverse of 1 is nothing but pi by 4, as it is the previous question. As it is, x equals to tan theta, we are choosing the both the cases in the previous problem as well as now also. We done the same process, derivative with respect to x, then dx equals to sec square theta d theta, as well as the we are changed the lower limit and upper limit is also. So now, therefore, what is the given question here? Integration 0 to 1 sine inverse of 2x by 1 plus x square dx. It is equals to integration 0 to pi by 4 sine inverse of 2 tan theta by 1 plus tan square theta, because same. X value we are choose the tan theta. X square value now become tan theta, tan square theta. And we got the dx value is sec square theta d theta, as it is the previous problem. But yet small change here. We know that sine 2 theta formula. Sine 2 theta formula is 2 tan theta by 1 plus tan square theta. Sine 2 theta formula is 2 tan theta by 1 plus tan square. This is the total, is simply the value is sine 2 theta value only. 2 tan theta by 1 plus tan square theta is nothing but sine 2 theta. So I have to replace this. I have to replace this. So it is integration 0 to pi by 4. Sine inverse of this total value is sine 2 theta. Sine 2 theta and sec square theta d theta. Again, we know the formula, inverse trigonometry. Sine inverse of sine theta is theta only. Sine inverse of sine theta is theta only. So what is the value now? Sine inverse of sine 2 theta, the value is 2 theta only, because instead of the theta variable here 2 theta is there. So it is now integration 0 to pi by 4, 2 theta, sine inverse of sine nothing but theta, 2 theta, 2 theta into sec square theta into d theta. 2 I am writing outside. It become now integration 0 to pi by 4 theta into sec square theta into d theta. Let is equation number 1. Equation 1. Dear student, and observe this. It is the which form? Integration u into v formula. U into v. This is the one function, and this is one more function. Theta into sec square theta is u into v formula. So we have to go. We are going to follow the integration by parts method. It is in the form of which form? Integration u into v dx. It is equals to u into integration v dx minus integration u dash into integration v dx all dx. Where how you can choose the u? I am given the clue also. I let clue. I means inverse trigonometry. It is there in the given question. We got that question is theta into sec square theta. There is no inverse trigonometry. Then next one is L. L means logarithm. No, it is also there is no logarithm function. And A is algebraic. Is there algebraic? Which is the algebraic is here? Theta is the algebraic function only. Theta is algebraic only. The variable is theta here. So therefore, we choose here u equals to theta and v equals to sec square theta. U equals to theta, v equals to sec square theta. And therefore equation 1 implies 2 into integration 0 to pi by 4 theta into sec square theta d theta. 2 as it is. U value is theta. U value is theta. I'm writing outside. Integration of sec square theta minus integration 0 to pi by 4. Integration 0 to pi by 4 u dash. That means theta dash. That means theta derivative with respect to the same variable. Into integration sec square theta d theta and all d theta. I'm going to using integration u into v dx. It is equals to u into integration v dx minus integration u dash into integration v dx. What is the value now? 2 as it is, theta as it is, sec square theta integration. Sec square theta integration is tan theta. Sec square integration is tan theta g, and the limit is 0, lower limit is 0, upper limit is pi by 4, minus integration 0 to pi by 4. Theta derivative with respect to theta. X derivative is 1 with the same variable x. Theta derivative with the same variable theta value is 1. And the integration of sec square theta again tan theta d theta. Now in the first part, first term substitute theta value is pi by 4. It become now pi by 4 into tan pi by 4. Theta, first theta into tan theta is there. Substitute the upper limit pi by 4 into tan pi by 4. And substitute the lower limit is also now become 0 into tan 0. 0 into tan 0 minus integration 0 to pi by 4. Integration of 1 into tan theta, nothing but tan theta. Integration of tan theta is log of sec theta. You learned already in the 6th chapter. Integration of tan theta, log of sec theta. Lower limit is 0, upper limit is pi by 4. So now its value is tan pi by 4 value is 1. And into pi by 4 is there, so pi by 4. And its value is become 0. And apply the now, substitute the upper limit. So log of sec pi by 4. And substitute the lower limit now, minus log of sec 0. So it will be not there because we have already substituted the upper limit and lower limit. So what is become now? 2 into pi by 4. I multiply the 2 also. 2 into pi by 4 minus 2 log of sec pi by 4. Sec 45 degrees. Secant 45 degrees. Secant 45 degree value is root 2. Secant 45 degrees value is root 2. So minus 2 into log of root 2 log of secant 0 degree. Secant 0 degree value is 1. Secant 0 degree value is 1. But log 1 value is 0. Log 1 value is 0. So it is remaining now pi by 2 because 2 and 4 will be 2 ones are 2 fours are minus 2 log 2 2 minus 2 log root 2 log 1 value 0. No need to write is here. So it is logarithm. The coefficient become the exponent, especially in the logarithm. It is a minus log root 2 whole square. So root 2 whole square nothing but root and square get cancelled. Root and square get cancelled. Is become now pi by 2 minus log 2. Pi by 2 minus log 2. So integration 0 to 1 sin inverse of 2x by 1 plus x square dx equals to pi by 2 minus log 2. So today assignment, I'm going to close the today's session, as well as we have to find the first question now. So assignment homework problem, integration 0 to pi x by 1 plus sin x. Integration 0 to pi x by 1 plus sin x. Second question is integration 0 to pi 1 by 3 plus 2 cos x, 3 plus 2 cos x dx. Third one is integration 0 to pi by 4 log of 1 plus tan x. Almost this is already completed. This is already completed. Integration 0 to 1 log of 1 plus
conclude the session,
x by 1 plus x square dx. Okay, sir. Just 1 minute. Fourth one, integration minus 1 to 3 by 2 modulus of x into sine pi x dx. And one more last problem. Fifth one is integration 0 to 1 x tan inverse of x dx. So dear student, complete this 5 homework problem and submit to your concerned subject teacher. As well as I'm going to closing the today's session, as well as the chapter 7 definite integration is also completed, especially for the academic year 2021, because the COVID situation, the remaining chapter, the remaining part of this chapter is deleted for the this academic year. So chapter 7 is also completed. So we have to completed the 2 chapters, integration and as well as the definite integration. The next tomorrow I will go to start the differential equation. Okay. So today I will start the last chapter, chapter 8, differential